next up, take a look at a review of those 5 main companies that are in the SMB market space. So first up, JobBoss. Now, JobBoss on the left here is just kind of general company information. All these companies are privately owned, where they're located, how many customers they have. But JobBoss was purpose-built for mid-sized and small manufacturers in North America. They're really good at costing and production scheduling, and they have built-in aids for service and deliveries. One of the things I hear about JobBoss that's good is that it's very easy to use, has common sense guidance, so not a huge learning curve here, and it has safeguards built in, so it keeps you from wandering too far left and right. E2 Shop Systems, designed specifically for discrete manufacturers, supports made to order, made to stock, engineered to order, assembled to order, and mixed modes. Really good with scheduling and Gantt charts, so really good for your shop floor guys. Great with work queues and dispatching, and it's really strong in reporting, customer service, and again, that shop floor control. Epcor is a discrete manufacturing solution. It's a worldwide use company. It's modular, so you can turn on and off what you want. You want just accounting and inventory, fine. You turn that on, and then you don't ship anything, you can turn that off and not pay for it. So Epcor is kind of nice there in terms of that functionality. It has really great features around supply chain, product lifecycle management, performance management, and quality control of products, and a very, very good BOM system. Also very configurable and customizable. We talked about that earlier. Can be great, and you can also get yourself into trouble. So Global Shop, good company's robust intelligence capabilities, also supports a whole bunch of modes: engineered to order, made to stock, mixed mode, as well as project-based and repair-based. So they also are very, very good overhead and project tracking. And then Infor is the largest company in this list with over 90,000 customers. Now it's end-to-end built for manufacturing, supports the entire lifecycle design of products, and supports most modes: engineered to order, made to order, configuration, made to stock, and assemble to. Many robust features, really great around scheduling tools. So a lot of people like Infor for their scheduling tools. And it has a very tightly integrated general ledger, which you would think, hey, everybody should have a very tightly integrated general ledger, but a lot of customers say that Infor is good to use on that one. All right, so the things you really want to look at with your ERP systems is, what are you using now? Right? Are you going to try to keep any of that running? Some people would say, hey, that's fine to do. Sure, you can keep your accounting software, or you can keep QuickBooks. Don't keep QuickBooks. But can you keep these systems in place, and then is this going to work together with our new system? Is it going to work out of the box? Do I need to have a third-party integrator? Do I need to hire a programmer to make these things work together? Is there going to be custom modifications for this? So really, it can get in depth with what you're trying to do in terms of what works now and what I'm adding. And then will you be adding anything else from third parties? So for instance, some of the vendors listed here have great solutions for managing things like CAD drawings, and that's pre-built into software. But others use a third-party software tool to make CAD drawings work with their ERP system. And then do these integrations work well? So are they tied together? Or am I going to be jumping in and out of 2 different systems all day to get that data back and forth? And then is that a pain in the butt for me, or am I just running 2 screens anyway and I don't know?
So some of the challenges of the machining process are what we're going to evaluate today. So I'm going to look at before machining, during cutting, and then post machining. So there are first of all, there are multiple different types of machines: lathes, mills, etc. In addition to that, it's not just one company that makes them. There's Mazak, there's Akuma, there's Mitsui, there's all these brands of machines. How do you get all that information from the machines, from all these different controls, and speak the same language, which is, I assure you, a challenge. One of the things that the industry has called for is a common language, and that would be Machine Tool Connect, MT Connect. We've all heard about it, I assume. I can go into detail on that, but think of it as a communication protocol that everybody can speak the same language. It's really that simple. It's a one-way system, so it's from machine tool upstream. There are other ways you can address those issues, primarily through Ethernet protocols. I know FANUC Controls has a focus-based system for communication. So some of the issues that we deal with in machine tools is the part located correctly? Are tools cutting correctly? Can any tools cut faster? What's the health of the tools and the machine? How much tool life is left? Where's the machine in the process, in the cutting process? Was the part cut to the correct size? And is the surface finish correct? We're going to address a couple of these things here today. So what intelligent solutions are available? One system that we found to be incredibly popular in the industry is the Tool ID or Tool Connect system that essentially takes, it manages your tooling via RFID, a passive RFID tag that's mounted into the tool holder. Laser tool setting, that's in process on machine measurement. Part quality monitoring, tool monitoring, adaptive control, process status lights, automatic tool wear compensation, and machine monitoring software. So you can set your tools offline, which will give you more uptime on your machines by implementing a tool presetter. This particular product takes that RFID tag, which you see mounted into the tool holder, and we can send all that geometrical data, all this other critical information that you and your particular process have. Data stored in this RFID tag, so it's read and written by induction technology. We then can actually, on the machine tool side, place the tool and read that data off of it and then send it into the control. So you're eliminating that operator involvement of entering in, thumbing in geometry into the controls, offsets, making sure the tool gets in the proper tool pot, stuff like that. Tool monitoring with adaptive control is a product called TMAC. And what we're doing is well, first of all, tool monitoring reduces the high costs associated with breaking tools, lost production, damaging your machine or your parts. So tool monitoring is a good indicator of tool wear. We're actually using sensor technology, and that's where this all ties into IoT. We get IoT sensors, vibration, strain, horsepower, coolant flow, pressure. Think of TMAC as a product or a meeting house of all the sensor data. From there, we integrate to the machine tools in a fast way that can issue alarms, speed up, slow down the feed rates based on the load at the tool. So this kind of gives you a couple of examples of why tool monitoring is appropriate and why adaptive control is a real thing. I mean, that term gets thrown around a lot, but we have found, especially in the aerospace machining, anything hard nickel stuff, difficult materials to machine, adaptive control is a very powerful product, as well as castings, forgings, any irregularities in machine hardness. So we optimize cutting through that dynamic feed rate change. We reduce the cost of the consumable tooling by actually running the tools at the appropriate horsepower, load, or vibration. We're going to reduce scrap rate. So see, these are some of the IoT sensors that we provide: power, vibration, strain, coolant, pressure, and flow, as well as spindle speed. So there are certain specs out there in the world that require monitoring of machines. Predominantly in the aerospace industry, where failures have occurred in the air. We all don't really like to talk about it, but there have been forensic evaluations of parts that have failed, and they found a vast majority of them to be abusive machines. So being able to monitor the load on the tools, the coolant delivery, making sure that all those things are actually doing what they're supposed to is a little ahead of myself there on that one. Okay, so another product, this is actually at a customer. They found for throughput that being able to identify where the operator needs to go next is a critical thing. So they were utilizing one operator for two machines, which is good by most standards. And this is about 20 years ago. So what they wanted to do was do better. So they actually did, diagrams, spaghetti diagrams, to see how often the operator was walking in the course of a day. And they started seeing that operators would go into every control trying to figure out where they needed to go next. So they were constantly running around. By utilizing a smart light, or it's basically a stack light, an LED stack light, they were able to tell the operator at a glance, oh, I need to go there next, and develop their own schema so their operators can really save a lot of time there. It's another important thing to note is that all of these particular systems are talking in a common platform with MT Connect. So all this data is able to go to those OEE type platforms, which I'll discuss in just a few minutes. OEE are, the overall equipment effectiveness, I believe is what it stands for if it's sitting there empty. So once the part is removed, then we start looking at, and I'm going to back up here for a second, we're looking at, we've seen how to get the data from the tool into the machine tool. We're monitoring the machine tool as far as the health of the machine tool, the health of the tooling in it. And now we're, removing the part from the machine, getting that graphical, the geometrical data is critical. All of this ties in to the industrial internet of things as far as getting that data upstream, so you know what your part quality is, you know what your machine tool quality is. So another thing we can do is we can actually take the geometrical data from the part and analyze it, compare it to your nominals, your upper complements, and your reject limits, and actually automatically comp the machine tool back. What does that do? It eliminates the operator involvement from, let's face it, we're all human beings here. So, writing something down, transposing a number, taking an erroneous measurement, and then going over to the machine tool control. Getting into the control, getting into the proper offset page, keying it in. You could go the wrong direction pretty easily on a lathe. I've done it. And that was not my machine either. So, but my point is you have a lot of opportunity for error. So being able to utilize, I see the hook coming. He's creeping towards the front of the room.
Just giving you a couple minutes.
Okay. Analyzing, how that data goes in, and then also post-process data coming out, trending, doing all these things is really critical.
I'm going to give you a brief rundown of who FANUC is real quick because we don't have a lot of time. But FANUC is headquartered over in Japan at the foot of Mount Fuji. You can see a lot of the factories there down in the valley. We are by far the world's largest robot company. For here in the Americas, we've got about 2/3 of the market. So to put that in perspective, if you take everybody else, and I'll throw out some names that maybe people have heard of, like ABB or Motoman or KUKA and Adept and a lot of other companies, if you take all of them and you add them up and then you double it, that's about how big we are. So that's the size of our market just in the robot side. And fortunately, in the CNC side, I think most I was talking to, I think it was Bud, you said you had like 49 FANUC CNCs in your plant. So that's pretty common in the CNC side as well. We use our own robots in making our robots, which is a little bit George Orwellian, a little scary. We currently make about 5,000 robots a month. We just are building a factory now that's going to increase to 11,000 robots per month, so 130,000 robots a year. So there's more pressure on me to sell more. We can't. The market isn't that big today, but we see the future. That's the way the market is growing globally, especially in China, but especially here in the U.S. as well. So we see the future, and we want to be ready for it. As I said, I focus on the robots in the top part. Lower left is the CNC controls that many of you are familiar with. We also make some robo machines, as we call them. The Robo Drill, which is the milling and drilling machine, a wire EDM machine, and the Robo Shot, which is marketed by Millicron for the electric molding machine. All of those, the common thread, besides the controls, is the servo motor up in the upper left. FANUC is the world leader in servo control technology. We make the most servos. And you can see there are over 17 million installed, 3.5 million CNCs. And in the upper right, you see there are over 450,000 robots installed worldwide. We just actually, the 500,000th robot just came off of our manufacturing line recently. We are in every industry, every product that we touch every day. I mentioned automotive is the largest, but you talk about agriculture, aerospace, wood, food, paper, metal, electronics. All of those use robots. Most of them don't use them enough yet. The automotive is the big user, but that's where all the growth is. But we make the robots, but we rely on system integrators to make it work. So if you have an application, and we want to talk about it later, what I would ultimately do is probably engage one of these, or we have about 700 integrators across the U.S., and they all focus in different process specialties, whether it be packaging, machine tending, water jet cutting, welding, painting, you name it. And my job is to identify the application in your facility, say, yeah, that's a good robot job, and then bring in the right partner to make it work. Marshall here is basically, we have facilities all over the Americas, as you can see there. Some of you that may have our FANUC CNCs may have relied on our facility up in Pine Brook, New Jersey for some service out of that office. Actually over 500 field service engineers now throughout the U.S. And a pretty broad section of robots, everything from small pick-and-place robots that pick up about a pound, up to robots that can pick up almost 5,000 pounds. One of the big differentiators on our robots is, and it's across the board of the industry, the robots are very reliable, but much like our CNC controls, our robots are incredibly reliable with over 100,000 hours mean time between failures. Now getting into more about the market and robot applications. As I mentioned earlier, the robot industry is booming. The projections, as you can see there, up through 2022, and this is just one chart. I can pull 10 different charts from different organizations that all say the same thing, that over the next 5-10 years, the use of robots is just going to explode. A lot of that is going to be, fortunately for me, in general industry, outside the automotive area. As you can see there, 14% growth over the first 9 months of 2017 over 2016, and 11% in automotive related was 11%, in non-automotive was up 20%. So that's where the growth is. So we see a growth in manufacturing in both robots and machine tools. One of the biggest issues that I hear all the time when I was first joining FANUC was, well, you're here to take our jobs away. Well, the reality is that we don't have people to fill those jobs, and there's a skills gap coming. If you look at, and this is just one report from Deloitte, we're expected to have 2 million jobs go unfilled over the next, well, they're saying through 2025. We've got the baby boomers that are not going to be replaced, and then we've got other manufacturing jobs from reshoring, bringing jobs back to America. That's 2.7 million people that we need people for, and we have 3.4 million jobs rather that are likely to be needed, but only 2.7 million to fill those jobs. So robots are not taking jobs away, they're filling that gap. I look at it as, if you have a factory that's got 100 employees, and that factory can stay open with robots with maybe 80 employees and keep those jobs for 80 people, or it can close because it can't be competitive with parts that are being manufactured elsewhere. So that's another area where robots can keep jobs here in America. One of the things we talk about is, what's a job shop? And we look at it as any facility with a machine tool that's producing parts is a job shop. So if you look at a job shop owner, he has a choice. He can either manually operate that machine, or he can put a robot in front of it. And if you have an operator, you worry about consistency. Is that operator going to be as consistent at 8 a.m. as he is at 3 p.m.? Well, a robot's going to be just as consistent, or more consistent. It's going to be faster. It's going to do the same thing whether it's 8 a.m. or 3 p.m. or 3 a.m. You can get them, more bang for your buck, because an operator or a robot can now run 3 shifts. You need 3 operators to do that same machine over 3 shifts. You have other processes in terms of air flow and cleaning the work holding, and in blowing that can go all over the place. You can have a more controlled coolant and airflow with a robot. Got to make sure the part's seated right. Well, robot, you don't have to worry about that. because the robot's going to do it repeatedly every time. The key is that the robot's going to be more consistent. It's going to be there every day. It's not going to take breaks. It's not going to argue with the guy around the corner. There's a lot more benefits to a robot beyond just the labor savings.
Interesting. We talk a lot about technology, and I kind of feel like we're now down at the end where we're grinding it out. We're boilers, we're lighting, we're energy, stuff we still need. However, you put all robots in, you can turn the lights off. I'm done. You saved a lot of energy, and it's easy to go from there. But today, if you can't turn all the lights off, and you still have to make steam and heat and cooling and environment and processes, we want to talk about some ways that we can reduce those costs while still improving the building. So a little bit about lowering operating costs, improve the facility, so reducing energy costs, improve productivity, improve safety. So a little bit about our costs here. After labor, after materials, after those kind of things, energy is really one of the top costs in the industry, especially in manufacturing. But a lot of times we think that we really can't do much about it. So we're here today to talk a little bit about give you some ideas, some thoughts, and ways that we can possibly look at that and reduce our processes and facilities and still be profitable and have a good product. It's making building systems, whether it's lighting, mechanical, plumbing, more efficient while developing projects that have good return on investment. Typically in the industry, we're seeing a 30 to 50% return on investment on a lot of projects and simple paybacks of 1 to 3 years. A little bit about Rich Energy Solutions. As I mentioned, we're an energy solutions company where we operate in about 38 states. Billions of dollars worth of construction experience. We've been around a long time. So what do we want to do? We want to figure out ways that we can increase profits, and when we make those investments, get a return on our investment that's been maximized. So by looking at here I see LED lighting. We all know that LED lighting is a pretty good return, but quite often the question is it going to save the money that we think? How much does it cost? How do I get this done? And we're going to talk a little bit about some unique ways maybe to get those projects done. Improve employee productivity. I cannot stress how much the lighting has helped, guys. I'm going to show you a case study a little bit later. We walked back into the plant, Kingsbury, which makes the thrust bearings on Drummond Road in Northeast. One of the things we walked back on the floor after we did an LED lighting project there. Talk about quality control, safety, those kind of things. Really, those things do make a difference. And also take advantage of what's out there, whether it's incentives from the utility company, whether it's some of the new tax, 100% expensing now is out there, so it makes sense to maybe look at some projects that you didn't look at in the years past. 179D where we can get so much per square foot for energy savings that your accountant would be able to help you with. So there's a lot of ways to kind of increase the projects and the profits. So how do we go about doing this? I think everybody here, whether it's been home or at your plant, has said, well, I know that these projects kind of make sense, but are they really going to have the payback? Is it really going to get the job done? Am I investing in technology that's maybe going to be outdated? All these things start to go through your mind. So what are the steps? First, we have to analyze. We have to really analyze the existing mechanical, lighting, and plumbing systems, really take a look at what they're using, how much energy they actually using, not what we think, not what someone just kind of says on the spec sheet. What are we really using here? So we have to understand that first. And then take a look at, analyze the potential for building controls, optimization. We talked a lot about technology today. Yeah, well, we still grind it out with boilers and mechanical systems and cooling. There's a tremendous building management system opportunity out there now. So we can really track and monitor energy use. And once we have data, once we understand things, that's powerful, that's knowledge. We can start to take a look and understand patterns. Maybe we can reduce demand at certain periods, and there's things in our process that we can time differently. So, all kind of discussions. And once we understand what we're using,